Hello, Jitan. Welcome again to Mathematics 10A. So today we are down on the last topic for the second quarter. And it is about the arc length and the sectors and segments of a circle. For this lesson, we will illustrate arc length, sector, and segment of a circle. And then we are to use those concepts to solve problems on circles. Let's start with this problem. Peter is conducting a physics experiment on pendulum motion. His 30 centimeters pendulum traverses an arc of 15 centimeters. To the nearest degree, how many degrees of rotation did the pendulum swing? So the main focus of our lesson is to answer this question. How do the concepts about arc length and sector and segment of a circle facilitate finding solutions to real-life problems and making wise decisions just like the problem given? This module primarily focuses on illustrating arc length and the sector and segment of a circle and their application to real-life problems. To deal with these concepts, there is a must on understanding the area and the circumference of the circle. Let us start with the arc length and the circumference of a circle. Pi is very important in dealing with the circumference of a circle. We have the so-called pi theorem, which states that the ratio of the circumference to the measure of the diameter is the same for all circles. The perimeter of a circle is called the circumference. For every circle with circumference C and diameter D, the ratio of C and D is equal to pi. Pi is called the proportionality constant. Coming from the pi theorem, we have the corollary, which describes the circumference of a circle. It states that if C is the circumference of a circle with diameter of length d and a radius r, then its circumference C is the product of d and pi, or twice the product of pi and r. Let us take this example. One of the large trees in the park has a diameter of 10 feet. How long is the rope needed to put around its trunk? The problem shows an application of the circumference of a circle. Although the cross-section of the trunk does not illustrate a perfect circle, the length of the rope needed can be estimated with the use of the circumference formula. Solving for the unknown, we have the formula C is equal to the product of pi and d. Substituting the given, we have C is equal to pi times 10. So the circumference in terms of pi is equal to 10 pi feet, which is approximately equal to 31.42 feet. Therefore, the length of the rope needed to put around the trunk is 10 pi feet, or approximately equal to 31.42 feet. Another corollary of the pi theorem is the arc length, which states that in a circle, the ratio of the arc length given as L to the circumference C is equal to the ratio of the measure of the arc, theta, to 360. Take note that the measure of an arc, which is theta, is given in degrees, and the length of an arc, L, is given in linear units. Using the circle on the right, solve for the length of arc AB, given that the radius, segment AO, is 18 centimeters long and the arc AB measures 45 degrees. Solving for the arc length, we have the formula length of arc AB over 2 pi r is equal to theta over 360. Substituting the given, we have the length of arc AB over 2 pi times 18 is equal to 45 over 360. Simplifying both sides of the equation, we have length of arc AB over 36 pi is equal to 1/8. Using the multiplication property of equality, or simply cross multiplication, we have 8 times the length of arc AB is equal to 36 pi. And further solving for the arc length, we have 36 pi over 8. Expressing our answer in lowest term, we have 9 pi over 2, which is approximately equal to 14.14 centimeters. Therefore, the length of arc AB is 9 pi over 2 centimeters, or 14.14 centimeters. So, that's the arc length and the circumference of a circle. We will now move on to the sector, segment, and area of a circle. Starting with the theorem about the area of a circle, we have the area of a circle with radius r is the product of pi and the square of the radius. For example, the area of a circle is 49 pi square centimeters. Find the length of its diameter. Using the formula for the area, substitute all the given values. So we have 49 pi is equal to pi r squared. Then multiply both sides by 1 over pi to cancel out pi. After that, take the square root of both sides. Therefore, the radius will now be equal to 7 centimeters. We will be using the idea that the length of the diameter is twice that of the radius. So we have d is equal to twice of 7, which will be equal to 14 centimeters. So therefore, the diameter of the given circle is 14 centimeters. The idea of the area of the circle is essential in identifying the area of a sector. But before that, let us define first a sector. It is the region bounded by two radii of the circle and their intercepted arc. The area of a sector is a fractional part of the area of the circle. In reference with figure 8.4, the region bounded by the radii segment AO and segment BO, and arc AB is a sector of circle O. Another theorem, which is about the area of a sector, states that the area of sector AOB is the product of the ratio of the measure of arc AB, theta, to 360 and the area of the circle. Applying this concept, we have the given example. In relation with the figure on the right, find the area of the shaded region. Given are the radius, which is 14 centimeters, and theta, or the measure of arc ES, which is 30 degrees. Therefore, the unknown there is the area of sector EQS. Using the formula for the area of the sector and the given values, we have area of sector EQS is equal to 30 over 360 times pi times 14 squared. Simplifying the right side of the equation, we will have 1 over 12 times pi times 196. And further multiplying, we will come up with 49 over 3 pi centimeters squared. Therefore, the area of the sector is approximately equal to 51.31 square centimeters. Last but definitely not the least, we have the segment of a circle. It is a region formed by an arc and the chord having the same endpoints as the arc. Using the figure given, the space bounded by arc AB and segment AB is a segment of circle O. Since a segment is a region bounded by a chord and an arc, we can also solve for its area. And to find the area of the segment of a circle, subtract the area of the triangle from the area of the sector. So therefore, we will be using two different formulas to solve for the area of the segment. We have the area of the sector, which is theta over 360 times pi r squared, while for the area of the triangle, we will be using the formula 1/2 r squared sine theta, wherein theta is the measure of the arc and r is the radius of the circle. For example, find the area of the shaded segment in the given figure. Given are the radius, which is equal to 4 centimeters, and theta, or the measure of arc DG, which is 120 degrees. Since the unknown on the problem is the area of the segment, we may solve for the area of the sector and the triangle separately. For step 1, we have the area of the sector. Substituting all the given values, we will have the area of the sector, which is equal to 120 degrees over 360 times pi times 4 squared. Simplifying the right side of the equation, it will become 1/3 times pi times 16, which can be multiplied further into 16 over 3 pi square centimeters, which is approximately equal to 16 and 7,552 10,000ths square centimeters. Take note to express your answer in decimal to the nearest 10,000ths to estimate a more accurate answer. Second step is solving for the area of the triangle. Substituting all the given, we have area of the triangle is equal to 1/2 times 4 squared times sine of 120. Therefore, the right side of the equation will become 1/2 times 16 times the square root of 3 all over 2. Multiplying, we will come up with 16 times the square root of 3 over 4, which can be simplified further to 4 square root of 3 squared centimeters, which is approximately equal to 6 and 9,282 10,000ths. Again, express your answer in decimal to the nearest 10,000ths. So for the last step, we can now solve for the area of the segment. Substituting all the obtained values, we have area of the segment is equal to 16 over 3 pi minus 4 times the square root of 3, which is approximately equal to 16.7552 minus 6.9282, which is equal or approximately equal to 9 and 8,270 10,000. So therefore, we have the area of the segment approximately equal to 9 and 8,270 10,000 square centimeters. So that's all for arc length, segment, and sector of a circle. If you have any questions, reserve all of those for our synchronous meeting. See you and God bless G10.